The first video I did, just a few minutes, short video on balancing this equation. We're now going to work with the balanced chemical equation and do a mass-mass calculation or stoichiometry. So we balanced it. We came up with a 2 right here. 2 C2H6s plus 7 oxygens is going to form 4 CO2s and 6 H2Os. You can't do mass-mass calculations until you have balanced the equation. These are going to be the stoichiometric ratios. They're going to tell us things like, well, we're given, this is what we're given. So in words, this might say, what would be the amount of CO2 produced if 98.5 grams of C2H6 burned completely? How much CO2 would that produce? So we're given the amount of C2H6 and asked how much CO2 is produced. So this is given. This is our unknown. This is what we want to calculate. And you can see we're starting out with a mass of this. This is ethane. And we're asked to calculate the mass of CO2 that would result. Now, the coefficients don't give us gram-to-gram relationships. It gives us mole relationships. Basically, what it says is that 2 moles, for every 2 moles of C2H6 that reacts, we're going to get 4 moles of CO2. That's what those coefficients are telling us. And we need to know that to solve this problem. The roadmap for solving this problem is to take the grams of C2H6 and convert it into moles of C2H6, convert that into moles of CO2, and then calculate the grams of CO2. And that would actually be our answer. That's what this question is asking us. Now, to convert grams of C2H6 to moles of C2H6, we need an important number, and that important number is the molar mass. We need to know the molar mass of C2H6, and we're also going to need to know the molar mass of CO2. So let's take the C2H6. It contains carbon and hydrogen. There are 2 carbons in C2H6, and the periodic table tells us that 1 mole of carbon would weigh 12.01 grams, and so 2 moles of it is going to be 24.02 grams. Hydrogen, we've got 6 of them, and 1 mole of hydrogen is 1.01 grams. So 6 moles of it is going to be 6.06 grams. So 1 mole of C2H6 contains 2 moles of carbon and 6 moles of hydrogen. How much does all that stuff weigh? We add these 2 numbers up, and it weighs 30.08 grams per mole. So we need that number for our calculation, and we need to know the molar mass of CO2. So similarly, we take it has carbon in it and it has oxygen in it. It has 1 carbon, and 1 mole of carbon is 12.01 grams. It has 2 oxygens, and a mole of oxygen weighs 16.00 grams, or 32.00 grams for 2 of them. And so if you add that up, you get 1, you get 4, 4. So this has a molar mass of 44.01 grams per mole. Okay, now we have all the numbers we need to do this. We know the molar ratios from the balanced equation. We know the molar masses of the two compounds that are of interest in this problem. You can see I ignored the oxygen and the water because I'm not asking that right here. This question isn't asking anything about the oxygen or the water. It's just saying if we had 98.5 grams of C2H6, how many grams of CO2 would be produced? We could ask all those questions. How much oxygen would it take? How much water would come out? But that's not this particular problem. So we start these problems with what we are given. And you can see I don't cut any corners. I write down it's 98.5 grams and what that is, C2H6. It's grams of C2H6. Now I want to convert grams of C2H6 into moles. So that's where we're going. That's the path we're going on. Here's where we're headed right here. Right on across here. So the very first thing we have to do is convert the grams of C2H6 to moles of C2H6. So I've got this conversion factor up here, but how do I use it? Well, I'm going to put grams of C2H6 down here and the mole up here. So 1 mole of C2H6 is 30.08 grams. And you can see that the grams of C2H6 cross out, and I have gotten to my first step there. I've converted the grams of C2H6 to moles. Now I want to convert the moles of C2H6 to moles of CO2. Well, moles of C2H6 need to come down here, so it will cross out with what's in the denominator. And moles of CO2 need to be in the numerator. And what are those numbers? Well, the balanced equation says 4 moles of CO2 will be produced for every 2 moles of C2H6 that reacts. And notice where we are right now. We've gotten to our second step. And then finally, we want to convert moles of CO2 into grams of CO2. So the mole of CO2 needs to be down here and grams of CO2 up here. And what is it? It's 44.01 grams of CO2 per 1 mole of CO2. And you can see by this calculation, we have converted grams of C2H6 into grams of CO2. Take your calculators and multiply all the numbers in the numerator together and then divide them successively by each of the numbers in the denominator. Divide. So if I do that, 98.5 times 4 times 44.01 divided by 30.08 divided by 2, I get 288 grams of CO2. 288 grams of CO2. Yeah, that sounds reasonable. And I'm reporting to 3 significant figures because that's the accuracy of the mass of C2H6 that we were given to start with. And there's your answer, 288 grams of CO2. Correct answer will have the right number, right significant figures, the right units, and what it is, CO2. It's grams of CO2. All right. So this equation we balanced previously. This is 2, 19, 12, and 14. And similarly, now the question really is, how much oxygen will be consumed when 44.6 grams of C6H14 completely reacts? So in this case, you need the molar masses of C6H14 and O2. So figure those molar masses. You are going to go, here's the path, grams of C6H14 need to be converted into moles of C6H14, and then you need to use the factors in the balanced equation to convert C6H14, moles of that, into moles of O2, and then finally, using the molar mass, you would calculate the grams of O2, and you'd have the answer to the question. This is stoichiometry. Okay, so continue on with some of these and work out these problems, and perhaps hopefully in class we can give the answers to the rest of these and see how you did.